Most of us think of black holes as the monsters of the universe, massive, terrifying voids that swallow stars, planets, even light itself. They're the ultimate symbol of destruction. But what if I told you black holes might also be connected to something deeply personal, your own memories? At first glance, that sounds impossible. How could something millions of light years away have anything to do with the fragile thoughts in your brain? But when you peel back the layers of science, philosophy, and a little bit of speculation, you start to see strange parallels. And those parallels may reveal something profound about how the universe itself stores and preserves information. Black holes as cosmic memory banks. Scientists have long wrestled with one of the weirdest puzzles in physics. What happens to information that falls into a black hole? Imagine throwing a book into one. The matter inside gets crushed beyond recognition, sure. But what about the information contained in that book? Every word, every page, every sequence of ink marks, does that information just vanish? For decades, physicists thought yes. But then Stephen Hawking proposed something shocking. Information can't truly be destroyed, even inside a black hole. Instead, it must somehow be encoded on the surface of the black hole, like a cosmic hard drive. This led to the famous black hole information paradox, which is still debated today. But the key idea here is striking. Black holes might actually store everything they consume. Not as we'd recognize it, but as encoded data written into the very fabric of space-time. Doesn't that sound eerily familiar? Because that's exactly what your brain does with your memories. How your brain stores memories. Inside your head, memories aren't stored as little movies you can replay. They're patterns of connections, neural pathways woven between billions of neurons. Every experience you've ever had, every face you remember, every smell, every heartbreak, it's all preserved as complex patterns of electrical and chemical signals. And here's the eerie part. Just like black holes, your brain doesn't let information vanish easily. Even memories you think you've forgotten leave behind faint traces, shadows in your neural networks, waiting for the right trigger to bring them back. So on one scale, you've got the largest objects in the cosmos storing data in warped space-time. On the other, you've got the 3-pound organ in your skull doing the exact same thing. One is cosmic, the other biological. But the principle is hauntingly similar. The universe finds a way to remember. Time, memory, and gravity. There's another connection too. Time. Black holes bend time itself. The closer you get to one, the slower time moves relative to the outside universe. At the very edge, called the event horizon, time practically freezes. Memory works a little like that. Some moments in your life pass in a blur, you barely remember them. But others, especially emotional ones, feel like they last forever. A single instant can get stretched, burned into your brain as if time itself slowed down just for you. The physics of gravity and the psychology of memory both distort time. One bends it with mass, the other with meaning. Yet the effect is the same. Certain moments linger at the edge of forever. The holographic principle and your mind. One of the most radical theories in physics is called the holographic principle. It suggests that everything inside a black hole is actually encoded on its surface. Imagine a 3-dimensional object projected from a 2-dimensional film strip. According to this idea, our universe itself might be a hologram, with everything we experience encoded on a distant surface of reality. Think about your memories again. When you recall a moment, you don't replay it perfectly. You reconstruct it. Psychologists call memory reconstructive because your brain pulls fragments from different areas, sight, sound, emotion, and reassembles them into the illusion of one coherent scene. That's basically a hologram. A whole 3D picture made from scattered 2D slices of information. Black holes might be projecting information about everything they consume, just as your brain projects the illusion of a complete memory. Forgetting and the black hole firewall. Of course, not all memories survive. Trauma, age, or simply the passage of time can erode them. Some fade, some fracture, some disappear completely. But do they really vanish? Or are they stored so deep in your brain that you just can't access them anymore? Black holes raise the same question. Some scientists propose that a kind of firewall exists at the edge of a black hole, burning away information as it crosses the horizon. Others argue the information isn't destroyed, just hidden in ways we don't yet understand. The similarity is uncanny. Just as your brain guards certain memories behind walls you can't cross, black holes may guard their secrets behind the event horizon. In both cases, information exists, but access is limited. Entanglement, consciousness, and black holes. Now here's where things get even stranger. Quantum entanglement is a phenomenon where particles become linked so that the state of one instantly affects the other, no matter how far apart they are. Some physicists believe entanglement could explain how black holes process and store information. Meanwhile, in neuroscience, there are theories that consciousness itself might rely on a kind of entanglement inside the brain, connections so fast and subtle that they transcend ordinary physics. If true, this would mean both black holes and brains rely on the same quantum trick to store and transmit information. The cosmic and the personal, bound by the same hidden rules. Black holes as metaphors for memory. Even if you step away from pure physics, the metaphor is powerful. A black hole is a place where nothing escapes. Once something crosses the event horizon, it's in there forever. Isn't that just like memory? No matter how much you try to forget, certain things stay locked inside you. They warp your emotional landscape, bending your inner gravity. Some memories are small, light, you barely notice them. Others are so heavy they bend everything around them. Just like black holes of different sizes, memories come with different masses. But the biggest ones, the traumas, the loves, the turning points, they reshape the entire fabric of who you are. Are we living in a remembering universe? All of this leads to a haunting question. What if the universe itself is one giant memory? If black holes encode everything they swallow, if reality itself might be a hologram of stored information, then maybe existence is less about matter and more about memory. Maybe the universe doesn't just exist, it remembers. And if that's true, then your memories are not small, fragile things. They are echoes of the same process that governs galaxies. Every time you recall a moment, you're participating in the same mystery that drives black holes. Your life is written into the cosmic memory. Black holes and memories seem like opposites. One is vast, impersonal, cosmic. The other small, intimate, human. Yet the more we look, the more they mirror each other. Both bend time. Both refuse to let information truly vanish. Both reconstruct reality from fragments. And both may be part of a larger truth, that everything in the universe, from galaxies to neurons, is bound by a need to preserve information. So the next time you think about a memory you can't shake, or a moment you wish you could forget, consider this. You are not so different from a black hole. You are a remembering machine, shaped by gravity and time, storing echoes of everything you've ever consumed. And just maybe, when we finally unlock the secrets of black holes, we'll discover we've been carrying those secrets inside us all along.